Soviet scientists discovered and investigated a new class of tornado-like whirled flows, formed either by merging specially directed gas or liquid streams, or by making these streams circumvent surface reliefs in the form of three-dimensional concavities or craterlets. Man-made tornadoes like this produce two effects of practical importance. They intensify significantly the heat and mass exchange and decrease hydrodynamic resistance, provided the three-dimensional concavities conjugate smoothly with the originally smooth surface, while tornado-like streams are formed in accordance with the correctly solved hydrodynamic equations. The tornado-like streams are stable in a wide range of flow rates of gases and liquids, leading to their self-organizing, including at the time of circumventing a surface with a three-dimensional concavities relief. At the time of circumvention, intensification level of the heat and mass exchange depends to a large extent on the geometric parameters of the three-dimensional concavities of a power exchange surface and on the density of a heat flow on it. The leading growth of the heat transfer as compared with the hydraulic loss is a major feature of the heat exchange process in the self-organizing of tornado-like streams on a three-dimensional concavity surface, which makes it different from a similar process with a smooth surface being circumvented, or the heat exchange intensified in some traditional way. Making use of tornado-like flows with so favorable characteristics in heat exchange apparatuses, various purpose boilers, separators of the kind gas-liquid, liquid-gas, liquid-liquid, provides for developing more economical power generating and power exchange machines and units, conduce to decreasing materials consumption and raising their functional efficiency. For instance, using the effects accompanying the self-organizing of tornado-like structures, the size of heat exchange apparatuses has been significantly reduced as compared with the standard ones, while the heat exchange productivity W has been retained. Cooled blades of aircraft gas turbines and power exchange canals with a three-dimensional concavities regular surface relief have been developed and put to use successfully. The usage of this kind of blades was prompted by their ability to prolong service life and increase the takeoff thrust of a gas turbine engine. Another way tornado-like flows are efficiently used is to cool high-intensity power exchange surfaces of heat-releasing uranium elements. When heat-releasing elements with a cratered power exchange surface were water-cooled under the pressure of 0.3 megapascal, they ensured stable functioning of neutron targets at the electron accelerators with a heat flow density of more than 40 megawatts per square meter. The cratered heat exchanger surfaces raise the functional efficiency and prolong life of the apparatuses. Heat exchangers like this need less material to be made of and get less contaminated if the flow is impure or dusty. The self-organizing tornado-like flows owe their efficiency and thermohydraulic characteristics to their genesis and evolution. With the laminar mode of circumvention of a three-dimensional concavity, a specific symmetrical structure gets formed. With the increase of the flow rate, the symmetrical structure becomes asymmetric. Further increase brings about a non-stationary condition, that is, change of orientations of tornado-like structures, which suck in effectively the heat carrier from the boundary layer and eject it into the flow core. Tornado-like streams are also formed by a special system of radially convergent canals, wherein the particles of the continuum acquire the flow rate value and direction they need to form a tornado at the moment of their merging in a tornado-forming chamber. The calculating of all the parameters of this kind of self-organizing is based on the correct solving of the non-stationary equations of hydrodynamics, obtained on condition that there are no secondary vortexes, but the basic eddy in a given whirled flow. In this sense, the created whirled flow is irrotational. The experiments run on these devices show that the value of their flow rate pressure characteristic is at least twice that of a traditionally formed flow. In other words, the whirled tornado-like streams are a favorable example of forming low potential flows. These flows need relatively low pressures. The structure of a tornado-forming chamber provides for combining naturally the concentration of the continuum's energy dissipated in surrounding space, making the formed flow laminar, and converting its energy more efficiently. While watching the model of a tornado power generating set in operation, we can see to what a great extent it converts energy of a gas flow into mechanical energy. This manifests itself in the relative rotation of the turbine and their tornado-forming chamber, which concentrates the energy of a supplied flow and forms a laminarized whirled flow. Analogous with this kind of currents are natural whirled flows like whirlpools in riverbeds, to be normally found over natural hollows, huge rings at seas and oceans, and natural tornadoes. To convert energy of gas and liquid flows, there have been created tentative tornado-like currents generated by wind power in special towers. Systems like this were first developed in the United States and called Tornado Wind Energy Systems, or TWES. Unlike the TWES, which do not provide for joining smoothly the lines of the flow outside the tower with the lines of the flow of a whirl formed there, we have developed a tornado-forming apparatus which makes it possible to carry out this kind of joining on the basis of correct solutions of the non-stationary equations of hydrodynamics. This excludes extra loss caused by a flow line deviation and the development of harmful secondary currents. As we develop tornado-forming devices, we proceed from the assumption that the process should be carried out in conditions analogous with those wherein natural tornadoes are formed. This principle provides for developing highly efficient tornado-forming apparatuses and technologies in practically every sphere of power generation and power consumption, wherein the motion of gases and liquids or their two-phase or multi-component mixtures is used. An interdepartmental center for tornado power exchange has been set up at the Kurchatov Atomic Energy Institute in Moscow. The center elaborates and puts out highly efficient various-purpose heat exchangers, converters of solar and wind energy, hydro energy, various-purpose ventilation systems, separators, burners, Ranks tubes, and other devices operating on the basis of tornado effects. Your requests are most welcome.